Okay, this is Geometry Final course revision. So we have these over here, and then we have the grids, and then we have the grid questions. I mean the extra questions here. So if you want to study, it's these and this. Okay, this is the sheet that you guys don't have. Okay, um, if if you want to skip, okay, do these three. One of these, or actually one of these four, will come in the written tomorrow. Tomorrow after when I don't know, whenever the final is. Uh, so let's start. I'm gonna go a bit fast because يعني, they're very easy. Okay, here find x when the angle is in the exterior, then you subtract and divide by 2. So 100 minus 40 divided by 2 equals x. So I'm gonna get 60 divided by 2, so it's 30. Correct? Yeah. Here, this angle here. Okay, remember it's not a tangent. This is an exterior angle of the triangle. So this is gonna be equal to this angle plus this angle. Okay, this angle here is half of this 100, right? Because it's inscribed. So here it's 50. It's half of 100. Then this angle here, it's half of 120, so it's 60. So x will be 110. Okay, this is an exterior angle. It's not a tangent. It would only be equal to the angle on the side if they drew it like this, if it was a tangent. And they asked for this here, okay? So is the answer 110? Yeah. Find x. So if it comes in the exam, just divide by 2, and add. Okay, find x here. Okay, it's in the exterior again, so subtract and divide by 2. So 95 minus 30 over 2, you get 65 over 2, which is a decimal. Yeah, 32.5. Okay, question 17. Find x. Okay, x will be inscribing this arc over here, this blue arc. Okay, just connect the endpoints of the segment. Okay, can we find the measure of the arc? Yes, we can. Okay, this 80 is inscribing this arc 2, right? So we can find arc 2 by multiplying 80 by 2, we get 160 over here. This this 95 is inscribing arc 1, and how can we find arc 1? You just multiply 95 by 2. 95 times 2 will be 190. Okay, so we found this arc here and this arc 1. Okay, we know that x is half of this big arc. And do we know what the big arc is? Yes, it's 160 plus 190. Okay, 160 plus 190 over 2, right? Because it's half of the big arc. Okay, 160 plus 190 will be, I think, 350. 40. 350 over 2, which is 175. Okay. Another way you could do is just add 80 plus 95 if it comes in the computer. Is it 175? Yeah. Okay. Question 18. Find x. X is this arc over here. Yeah, x is this arc over here. So over here, x is going to be this blue arc. Okay, I'll make it red so you guys can see a bit better. Okay, it's going to be this red arc. And what do we have given? Okay, we have the exterior angle, right? The exterior angle to the triangle. Okay, remember when it's part of the triangle, then it's exterior angle. What is the exterior angle equal to? The remote interior angles plus each other. So if this angle, let's call it y. Okay, y plus 20 would be equal to 45 because the exterior angles equals the sum of the remote interiors. Okay, so y plus 20 equals 45. So y equals 25. But they want the arc, and this is inscribing the arc. So this is half of the arc. So 25 is half of the arc. So the arc is double the angle. So it's gonna be 25 times 250. Okay, is this correct? Yeah. Question 19. Find x. Okay, look here. We're working with these two arcs, right? Since it's inside the circle, so then it's gonna be the sum, right? But we want this angle here. But we have this 80. How do we find it? We just subtract by 180. Why? Because they're both on the same line. And they form a linear pair. When two angles are on one line, that means their sum is 180 because they form a linear pair. So if this is 80, 180 minus 80, that means this angle over here is 100. So 150 plus x, always the sum divided by 2 equals the one in the inside. So 150 plus x divided by 2 equals 100. You're gonna get multiply by 2. You're gonna get 150 plus x equals 200. Subtract by 150. You're gonna get x equals 50. Is that correct? Yeah. Okay, if you see this, x is the same. It's gonna come 100%. X is the same as this angle. Okay, it's a theorem. 79. That's it. Question 21. Find. Okay, this is very easy. When it's in the interior, we add. Remember, so x plus 50 over 2 equals 70, and they actually gave us the arc we need. Sorry, the angle we need. Multiply by 2, you get x plus 50 equals 140. You're gonna subtract by 50, you get 90. Okay, question 22. They said 1 to 20, 15 to 24. Okay. Uh, what is the value of x? Since now it's outside, you subtract 100 minus 48 divided by 2, which is going to be 51. No, 26. Yeah, 26. 23. Okay, you have x's over here. See, this is equal to this, right? This is equal since they intercept the same arc. Can we find this? Yes, we can. If this angle is x, or no, let's call it y. Okay, if this angle is y, this angle is also y because it's an isosceles triangle. Okay, so if it's an isosceles, the base angles will be congruent. So 2y, right, they add up to 180 in a triangle. So 2y plus 52 equals 180. You can get 2y equals 128. You're going to get y equals 64. Okay, so x should be 64 degrees. Yes, 64. Question 24 is the last one we need. Oh, we don't need this. Okay, nice. In the figure below, S is tangent to the circle at R. What is the value of y? Okay, if this is 74, that means this over here is 74. And this angle over here, okay, is half of y, right? So let's call this x. Okay, if this is 74, this is 74 as well, because they're base angles, right? Can we find x? Yes, you can. 180 minus 74 minus 74. You're gonna get 52. Okay, and this x is half of the arc, so y is double of 52. So y equals 52 times 2, which is 104. My bad. Okay, equals 32. And double of 32 is going to be 64. My fault. Is that all that's required here? 21, 22, 23. Okay, and here until 24. Okay, yeah, now 1.4. Okay, question, 1.4. Here they only want from question 41, but in my paper it says from 39 to 43. 44. Yeah, so here always remember the product equal to each other. So 6 times 2 equals x, 8 minus x. So you're going to get 12 equals 8x minus x squared. Okay, can we take everything to one side? Let's take everything to the left. We're going to get x squared minus 8x plus 12 equals 0. Can you factor this? Yes, you can. You're going to get x minus 6, x minus 2. So you're actually going to get two solutions. Yeah, you're going to get two solutions. You're going to get x equals 6 and this equals 0 and x equals 2. And if you try both out, by the way, they will both be equal to 12. Okay. Part B, is it two solutions? Yeah. Part B, if you got a negative answer, then it will be rejected. But as long as it's positive, it's fine. Okay, here always remember, whole times exterior. Okay, whole times exterior equals whole times exterior. Okay. In this case, the whole is 22, and in this case, if this is x and this is x, that means the whole is 2x. Okay, so in this case, the whole 22, the exterior part is 12. Okay, here the whole is 2x, and the exterior part is x. Okay, 22 times 12 is 264, and 2x times x is 2x squared. Divide by 2 on both sides, you're going to get x squared equals 132. So you're going to get x equals root 132, okay, which doesn't have a root, so it's going to be, it should be 2 root 33, if you do it on a calculator. Yeah, 2 root 33. Just put it into a calculator, okay? If, in case you don't know how, 132 is expressed as 33 times 4, and you can take the 4 outside, it becomes 2 because the square root of 4 is 2, and you're going to get 2 root 33. 33 can be simplified further. Okay, part C. Now it's a tangent, so since it's tangent, so it's going to be tangent squared, okay, equals whole times exterior, okay? And so it's going to be x squared equals the whole thing, which is 6 plus 4, which is 10, okay, times 4. You're going to get x squared equals 40, x equals root 40, which is 2 root 10. So, yeah, 2 root 10. Okay, question 40. Its statements and reasons, they either get it computed, they either get it written. In both cases, please memorize it, okay? You have PM equals PN. No, sorry, you have two circles intersecting at A and B. They told us that PN and PM are tangents. Prove that PM equals PN. This segment is equal to this segment. Okay, the first thing they said is PM squared equals PA, the exterior part, times PB, which is the whole thing. What is the reason for that? Here, they just put secant and tangent with common endpoint. You could say that, I guess. I mean, since it's in the course division, you can say that. But the theorem is the length of the tangent squared is equal to the whole length of the secant multiplied by the length of the exterior part of the secant. If you say that as well, that's fine. Same thing for reason 2, okay? And since they both, now you say P, okay, transitive property means two things are equal because they're equal to something else. PM squared is equal to PA times PB, PN squared is equal to PA times PB, so then PM squared equals PN, right? So PM squared equals PN squared. Why? Because of the transitive property. They're both equal to PA times PB, in case it comes, okay? Here, yeah? Okay, then it became PM equals plus minus PN, which is the square root principle, no? So you can just say simplifying. Okay, that's it. And then PM equals PN, they remove the plus minus because a segment always has to be positive. It can never be negative. Okay, question 41. Refer to the figure below. Okay, L is the tangent. How do you find X? Since X is the tangent, it's square. Oh, what? Okay, X squared equals the whole 40 times the exterior, which is... Okay, so X squared equals 400. So X equals 20. Okay. Then question 42. What is the value of X? Same thing, whole times exterior. The whole thing is 10 plus X. Wait, did I skip? Oh shit. 42. X times 9 equals 6 times 6. So 9x equals 36. X equals 4. Okay. Question 43. Whole times exterior. The whole thing is 10 plus X. The whole thing is 40. Oh, is that 40? Yeah. Okay, so 10 plus X the whole times the exterior 10. Okay. Equals whole 40 times the exterior 16. Okay, you're gonna get 100 plus 10x equals, man, what the fuck is this? 32, 64, 640. Okay, subtract by 100, you're gonna get 10x equals 540. You're gonna get x equals 54. Is that correct? Yeah. Okay, is that it here? Yeah, so 4.6 now. Okay, for 4.6, 25, 27, here it says 25, 26, 27. So we'll go through them all. Okay, the rules for sine, cosine, and shift sign, okay, of any theta, shift sign of any x, okay, will get you theta, okay. You never get only one solution. Your first solution will be theta plus 360k, always plus 360k, unless in the question they restrict it and they say theta in between 0 and between 360 or something like this. If they say this, then you don't write 360k, okay. So your first answer is always the answer you get after doing shift sign. Your second answer will be 180 minus theta, and you always have the plus 360k. Then for shift cosine, if shift cosine of x equals theta, you always put plus 360k. Okay, what's your second solution? 360 minus theta plus 360k on the side. Then for tan, for shift tan of x, you're gonna get theta. Yeah, so for tan, it's not plus 360k, it's plus 180k. Okay, and the second solution will be, I think, 180 plus theta plus 180k. Okay, the most important ones are sine and cosine. Tan is not really, okay. So yeah, I checked it. It's 180 plus the angle, and you always put plus 180k. So here, okay, by the way, be careful whether you're working with degrees or radians. Okay, how do you know? Well, they're saying pi in the multiple choice. So you're working with radians. So on your calculator, you do shift sign, okay, radical 3 over 2, okay, and you're gonna get 1 over 3 pi, okay, in radians. Change your calculator to radian. Okay, so your first solution will be 1 over 3 pi plus 360k, but we're not working with degrees. So over here, when I told you do 180 minus plus 360k, since we're working with pi, you don't say 360, you say 2 pi, okay, because for every pi is 180 degrees. So if you were to say plus 360k, it's the same as saying 2 pi k. 2 times 180 is 360, so that's the same thing. And here, when I say 180 minus, since I can't do 180 minus in radians, instead of doing 180, what do we say? Pi minus theta, okay, plus 2 pi k. Okay, so in this case, my first solution will be 1 over 3 pi plus 2 pi k. صح? Okay. My second solution, okay, what do? We do 180 minus, but since I'm working with pi, I have to do pi minus. Do pi minus 1 over 3 pi, okay, on your calculator. If you do pi minus 1 over 3 pi, okay, you get 2 over 3 pi. So your second solution is 2 over 3 pi plus 360k, but what do we say? We say instead of 360, 2 pi k. Okay, these are your two solutions. So 1 over 3 pi, where is it? Pi over 3 plus 2k pi. 1 over 3 pi and pi over 3 are pretty much the same thing. Okay, this, okay, and then 2 pi over 3 is 2 over 3 pi, okay, plus 2k pi. Make sure to pick the one with 2k, not 1k. It's 2k because 2 times 180 is 360. We don't want 180k, we want 360k, right? If it comes multiple choice, you can just check them. Okay, to be honest, you can just check them. But because it came written in one of our periodics, so just in case it comes written, you have to do it like this, okay? Question 26. Okay, here it's tan, okay? So for tan, what do? We do, and this in radians, because it's in pi, huh? We do shift tan, okay? Radical 3 over 3 in radians, and you should get, you're gonna get 1 over 6 pi. And we always said for tan, it's plus 180k, right? Plus 180k. But we're working with radians, so are we allowed to use the numbers? No. Instead of 180, we have to say pi k. Okay? Because remember, tangent was 180k. Okay? This is our first solution. What's our second step to find the second solution in tangent? We always add 180. But since we're working with radians, can we add numbers? No, we have to add pi. Okay? So we have to add, our second solution will be 1 over 6 pi plus pi. And obviously plus 180k, so plus pi k. Okay, you're gonna get 7 over 6 pi plus pi k. So these are our two solutions, this one and this one. So so it's 5 pi over 6. No, we didn't get it. Is it 7 pi over 6 plus 2k pi? No, we said no, right? It's only for tangent, it's 1k pi. Okay, the third one, yes. Okay, the 4, we didn't get any negative, and it's gonna be the last one, k pi. 5 pi over 6 plus k pi. Okay. Again, if it came in multiple, you can just test each one out. Question 27, if 1 over 3 cosine squared plus sine theta equals 1, okay, and they gave you the restriction, okay, they want you to find theta. Okay, remember that sine squared plus cosine squared theta, okay, equals 1. So over here, you always want to get rid of the square, okay? So cosine squared theta, okay, if you take sine squared to the other side, cosine squared theta will be equal to 1 minus sine squared theta. This came in our written, I remember, in our periodic. Okay, so instead of cosine squared, I can put 1 minus sine squared. So 1 over 3, 1 minus sine squared theta, okay, plus sine theta equals 1. Let's take the 1 here. Minus 1 equals 0. Can I multiply the whole equation by 3 to get rid of the fraction? I don't like working with fractions, so let's multiply the whole equation by 3. We're going to get 1 minus sine squared theta, okay, plus 3 sine theta minus 3 equals 0. Can we do 1 minus 3? Yes, we can. So you're going to get minus sine squared theta plus 3 sine theta, okay, minus 2 equals 0. We can replace all the signs with x, so it's going to be minus x squared plus 3x minus 2 equals 0. We don't like having x squared as negative, so we're going to multiply the whole thing by negative. We're going to take negative out. It will be x squared minus 3x plus 2 equals 0. Can we factor this? Yes, we can. We're going to get x, which numbers are 2 and 1, right? So x minus 2, x minus 1. So our two solutions will be x equals 2, x equals 1, right? Okay, so that means here, yeah, you're going to get that sine theta, since these are two solutions. So that means sine theta equals 1 and sine theta equals 2. Can sine theta equal 2? No, it's rejected. Because sine can never be greater than 1 or less than negative 1. It's always, sine and cosine are always between negative 1, well, I'm here. Between negative 1 and 1, okay? So sine theta equals 2 is rejected. If I get sine theta equals 1, what will theta be equal to? Shift sine of 1 which is equal to 90 degrees. Here, why we didn't do 180, 180 minus 90 to find another solution is because they restricted it between 0 and 90 degrees. Okay, what do they want? Question section 4.7, all questions. All questions? Oh, it's just 5 questions. Okay. In ABC, okay, let's take this to so over here. Okay, so we have triangle ABC. It would be better to draw it if you get a question like this. Okay, ABC. Okay, they said BC is 6, AC is 8, and angle C is 38 degrees. Calculate length AB. When you have two sides and the angle between them, we're going to use the cosine rule. Okay, the cosine rule states that AB squared, okay, the side squared equals the other two sides squared, so AC squared plus BC squared, okay, minus 2 times the other two sides, 8 in this case, times 6, times cosine of the angle between them, cosine 38. Okay, you're going to get AB squared equals AC squared, yani 8 squared, plus 6 squared, minus 2 times 8 times 6 times cosine 38, and you get, I don't know how much do you get, cosine rule, okay, 4.93. Remember, it's squared, huh? Then part B, in this triangle, another triangle ABC. Okay, so we can erase the measurements. Okay, so AB is 10.2, AC is 13.3, CB is 9.1, and they want you to find angle A. Whenever you have three sides and you want the angle, again, it's the same rule, cosine rule. Okay, uh, but now when you want the angle, you can still use the same thing, by the way. You can still use the same thing, but I'll give you the easier way. Whenever you want the angle, it's just rearranging the equation. You take AC and BC to the other side, and divide by negative 2 times AC BC. So you're gonna get, if it's AB squared, right? If you take the other AC squared and BC squared, it become minus AC squared. Uh, wait, sorry. Angle A. Sorry, it should be BC squared. Sorry, it's the side opposite to the angle. So uh, angle A, so the side opposite to it will be BC. So BC squared, okay? And then you take the other two sides to the left. So like, imagine this was, because we're working with a different angle, okay? That's what I'm trying to say. So just to make it easier for you, how we get the cosine one, you just take everything to the other side. So you're gonna get AC squared minus AB squared over minus 2 times the other two sides, okay? AC times BC. Sorry, AB. AC, AB. Okay? This has nothing to do with part A. It's a completely different triangle, and they're asking for a completely different angle. Since it's a different angle, you always take the one opposite to the angle. That's the one. That's the first term. It's always the one opposite to the angle. Okay. You put this in a calculator. You get 9.1 squared minus AC squared 13.3 squared. Okay. Minus AB squared will be 10.2 squared over minus 2 times 10.2 times 13.3. Okay, you get something, and you have to shift cosine, right? So you're gonna get alpha equals shift cosine of whatever you get here. Uh, uh, Cosine, you get this. So here, what they did is they did plus and then minus at the same at the end. Don't do that. If you want to, it's fine. It's a different formula, but just so we stick to the same formula. Okay, well they just rearranged the equation, but you can use this formula here. Okay, cosine A. Okay, if you wanted to write it in formula terms, cosine A equals A squared. The side opposite to angle A will always be the side A. A squared minus the other two sides squared, minus C squared minus C squared, over minus 2. We're talking about A, so the other two sides would be B, C. Okay, this is how the formula goes. And then if you want the side A squared equals the other two sides squared, okay, B squared plus C squared minus 2 times the other two sides. Okay, this is the general term of the cosine formula. Okay, in triangle ABC, again, we have to draw it. Okay, triangle ABC, A, B, C. AB is, okay, no, they gave me BC is 5, Angle B is 45. Okay. C is 60, and they want AC. They want AC. Ah, wait, what? AC. Okay. Okay, we can figure a few things out here. AC would be the side opposite to angle B, right? So we can call this side B. Okay. What we have? We have this side here, right? And it's actually opposite to angle A. Can we figure out angle A? Of course we can. Angle A would be 180 minus 45 minus 60, which would be 95. Okay. So we have all three angles in the triangle, and we have one of the sides. Can we find the second? Yes. Remember the sine rule. Sine of angle A over side A equals sine of angle B over side B. So sine of 95 over 5, it's the side opposite to it always, equals sine of 45 over B. So you do 5 sine 45 divided by sine 95, and you get B equals uh, 75. Measure. Oh, and I keep. How did I get 95? Aha, 75. Yeah, yeah. Okay, 75. Sorry, 75. Okay, there you go. You get 3.66. Okay. Part B in. Did I take part B here? Yeah. Okay, again, same triangle ABC. Sorry, AC equals 5. Let me just erase these. AC equals 5. BC equals 4. A is 30 degrees. Calculate the length of AB. AB. So this one's a bit trickier. Okay, they might actually get a question like this in written. So I think they'll get one of the shapes and something like this. And maybe one of the circles. But anyways, uh, always when you're finding these sides with the sine rule and the cosine rule, you always see, do I have the angle opposite to it, or do I have the side opposite to it? Opposite to AB is angle C, and I can't find AB if I don't have angle C, so I need to somehow figure out what's angle C. And since I'm working in a triangle, if I have the other two angles, then I can find this angle. But I don't have the other angle. But you can ask yourself, can I find it? I have the side opposite to it, and then the other angle, I have the side opposite to it also. And we know the sine rule, sine A over A equals sine B over B. So sine 30 over 4 equals sine B over 5. So I can find out angle B. If you do 5 sine 30 divided by 4, then shift sign, you're going to get angle B equals, what was it? 38.68. Okay, so if this is 38.68 over here, I can do 180 minus and get this is 112 point, is it 112? What is it? It's 111.32. 111.32. Okay, now can I find AB? I have the angle opposite to AB, and I have the other sides, the other two sides. Can I use cosine rule? Yes, I can. AB squared equals the other two sides squared plus each other, so 5 squared plus 4 squared, minus 2 times the other two sides, 5 times 4, times cosine, the angle in between them, which is 111.32. So you just do this and square root it because it's square, and you get, they did sine rule. Okay, that works, I guess. 9.32 centimeters. Okay, sine rule, cosine rule both works here. If they want to do sine rule, you can do sine 38.6 sine 30 over 4 equals sine 111.32 over AB. That works as well. Whatever you want. We said all of 4.7. Okay, given triangle RST, I think this will come. We always see this in every AMS. Okay, RST. Okay, with ST equals 10 root 3. R is 30. T is 60. What's the value of RS? Okay, RS, you always see, do I have the angle opposite to it? Yes, you do. So I want the angle and the side opposite. I have the angle, I want the side opposite to it, and I have the other angle and the side opposite to that angle. So that means I'm going to use sine rule. So sine 60 over RS equals sine 30 over 10 root 3. So RS is equal to sine 60 times 10 root 3 divided by sine 30, and you're going to get 30. Try question 31. Given ABC with BC is 8 root 3. Let's draw it. ABC. BC is 8 root 3. AB is 24 and measure of angle A is 30. What's the measure of angle C? Okay, we have, do we have the side opposite to angle C? Yes, we do. Okay, do we have, we also have another angle and the side opposite to it. So when working with two sides and the two angles opposite to them, then we're going to use sine rule. So sine 30 over 8 root 3 equals sine C over 24. So you do 24 times sine 30 divided by 8 root 3, and then you do shift sign because it's sine, huh? And you're going to get 60 degrees. 32 xyz, where's my mouse? xyz with xy is 7, yz is 12, angle y is 60. What's the value of xz squared? So they want it squared. Obviously, since we want square, so we're going to use cosine. So xz squared equals the other two sides squared minus 2 times 7 times 12 times cosine, the angle in between them, which is 60. And you're going to get xz squared. So you don't square root, you just, whatever answer you get here. Okay, you get 109. Okay, why was it 100? Because sine 60 is 0. Okay, sine. Okay, هلا what do you want? 4.8, 33, 36, 38. 33, 36, 38. Okay, ABCD is a regular tetrahedron of edge length 15. Okay, so 15. Since they said regular, يعني هيدي it's 15, هون it's 15, up it's 15, it's all 15. Okay, we want the length of height AH. Okay, as of right now, I actually can't figure out, like, I saw the solution and I really don't understand the solution. So for now, we're gonna skip it and come back to it once I get the solution, okay? If I do get the solution. Yeah. Okay, then we have 36. Yeah, this one's calm. It comes in the EMSs always. From a lighthouse, ship A. So we have this A, okay? Is at a distance of 6 radical 5 miles and a bearing of 40 degrees. So imagine this is our lighthouse, okay? Ship A, this is our lighthouse. It's 40 degrees. Yeah, so remember bearings are always clockwise, yeah? So A, let's say A is over here. Okay, this is A. Its bearing is 40 degrees and its distance is 6 root 5. Ship B is at a distance of 12 miles on a bearing of 310 degrees. 310 يعني go, hold up. So if you were to go 310 يعني 90, 180, 270 plus 40 degrees يعني هيك, something like this. Should be 50 degrees over here. So this would be 310 degrees. B would be over here and the distance would be 12 miles. Okay, then they say what's the distance AB, obviously. What's the distance between the two ships? Okay, so let's connect AB. Okay, if this is 310 degrees, then this angle is 50 degrees. Okay, that means this is 90. Okay, so you just do Pythagorean theorem. You do AB squared equals 12 squared plus 6 root 5 squared. You get, I don't know, what's the answer? AB is 324. Why are they using cosine rule? لا يا أخي, you can just do Pythagorean theorem. Okay, you can do Pythagorean theorem. I think also in the exam it comes 90 degrees. Just do 360 minus 310, you get 50, and add it to the angle here, you get 90 degrees. Okay. Then we want 36, 38. Okay, let's go 38. This is a cube, cuboid. Sorry. AB equals 10 centimeters. BC is 5 centimeters. CR is 6 centimeters. How many planes of symmetry does this cuboid have? So for part A, when they ask how many planes of symmetry, just memorize it. If it comes, they'll get you the same shape. Okay, it will be 3 planes of symmetry. These are the 3 planes of symmetry. Through the middle, straight down, and they just tilt it the other side. So it has 3 planes of symmetry. Calculate the angle between AR and the plane BCRQ. So AR, you'd have it like this, okay? And the plane BCRQ, wait, BCRQ. So here. Let me take this into open board so you can see it a bit better. I'll connect it with a straight line. Okay, from A to R. Okay, so we're gonna want this angle over here. So when always finding when working with these questions, okay, you're always gonna want a right angle somewhere. Okay, we can't just do this. Okay, you're gonna want to make some sort of triangle. So let's see, what triangle can I make? If I connect it to B, I mean they're not really, it's not really a right triangle. If I connect it to C though, I have a right triangle over here, right? This is right. Okay, so now I have this right triangle. I have this is 6 centimeters. Can I find this base over here? Yes, I can. If I have this is 10, and this is 5, and this is obviously a right angle, yeah? How do I find it? I do 10 squared plus 5 squared equals AC squared. And you're going to get AC squared equals 61. So AC equals radical 61. Okay? You just apply Pythagorean theorem. Okay? Now I have this angle over here. I have the side opposite to it. And I have the side adjacent to it. So what am I using? Opposite over adjacent. That's actually tan. So tan of R equals the opposite side, which is radical 60. Wait, no. Opposite. Okay, after taking a look at it, if you use this, you get radical 61 over 10. You're gonna get R equals 52.4 degrees, okay? Which is the same answer they got here. It's about 52 degrees. Okay, but after taking a look at it a few more times, the triangle I used was wrong because the way I'm doing it here, I'm measuring the angle between AR and the segment RC, okay? And we don't want that. We want between the plane BCRQ. So that means in my triangle, I have to take AB as the base over here. Okay, this horn. Okay. Okay, so over here we can find the side BR because this is obviously right, and 6 squared plus 5 squared gets me radical 61. I don't know how I got 10 radical 61. Okay, المهم radical 61. And this is right. Okay, so we have the right triangle. Can we find this angle? Same thing. We have the opposite side. We have the adjacent side. So we're gonna do tan of angle R equals the opposite over the adjacent. Okay, which is 10 over radical 61. Shift tan of this, you're gonna get 52 degrees approximately. So shift tan. Let me do on my calculator. 10 over root 61. You get 52.00 degrees. So we're done with section 4.8. هلا we're gonna go section 5.1. Yeah, so now we're on 5.1. Is it the same material here? Oh, 5.1 doesn't have any in the document. Okay. Yeah, I guess we're gonna do these 1, 2, 3, 4, 5, 6 questions. 1, 2, 3, 4, 5, 6. Okay, so all of 5.1. Calculate the area of the polygon EDCB. So you're gonna have to calculate the area of the parallelogram and the area of the triangle. Okay, the area of the parallelogram is obviously base times height. The base is 10. The height is the perpendicular distance times 3, so 30. Then you're gonna want the area of this triangle. This one's a bit tricky, but you have to know that these two triangles are similar because this angle is obviously congruent to this angle. Okay, and then this angle here is congruent to this angle because these two lines are parallel, so corresponding angles will be congruent. What does it mean if these two triangles are similar? That means the hypotenuse over the hypotenuse here is 10, okay, over the hypotenuse here, equals the base here, equals the base here over the base here. The base here will be EB. It should be similar to, if you have trouble finding out what's similar to what, you can see here that triangle EAB, okay, is similar to, we know AB is similar to AD, right? Okay, and we know that triangle A is congruent to triangle D. So if you have A in the middle, then you have to have D in the middle. Okay, and we know that DA, the hypotenuse, is similar to the hypotenuse. We don't need to know what do you call it? AB, so it should be DA, the hypotenuse. Hypotenuse, hypotenuse. And what's left? M. You can do this way, you can do it another way, or if you want the right angles, if you want, you can also do it. The right triangles, E and M, are the same. So E, A, B is similar to what's congruent to triangle E, triangle angle M. Congruent to A is D, and then we're just left with A. Okay. So we got that AB over AD, right? Hypotenuse over hypotenuse, which is the same here, by the way. AB over AD, okay, is equal to, we can say EA over MD, EA over MD. MD, so EA over MD, which is also equal to EB over MA, right? EB over MA. We know the value of MA, right? We know that MA is 3. Okay? We don't know what EB is, right? And we know that it's equal to 10 over 5. So, can we find EB? Of course we can. You're going to get EB equals 6. Okay, so you get 6 here. Can you find this over here? It's going to be 8 if you apply Pythagoras theorem, but you can also use, no, actually you can't use this way because we know that we don't know MD. We actually don't know MD, so you can't find EA. Okay, so you're going to have to use Pythagoras theorem. 6 squared plus x squared equals 10 squared. You're going to get this is 8. Okay, now that you know the base and the height of it, okay, you can just do 8 times 6, base times height divided by 2, and you're going to get 24. So the area here is 24. So the combined area is 24 plus 30, which is 54. Is that correct? 54. Okay, question 2. So it's a bit easier. Calculate the area of the okay. The area of a trapezium or trapezoid is base 1 plus base 2 over 2 times height. Okay, base 1 and base 2 are 5 plus 6 over 2 times the height. The height is the perpendicular distance, and to find the height, you have to find this distance, okay, the red distance. If we know this is 60, we know the hypotenuse is 4. We need the opposite side, okay? You do opposite over hypotenuse, which is sine. So sine 60 equals opposite, which is the height, let's just call it h, over the hypotenuse, which is 4. So you do 4 times sine 60, which is, I don't know, 4 sine 60. Just put this in a calculator and you'll get 11 radical 3. Okay. Yeah, that's it. If you want another rule for the parallelogram for the trapezoid, area of a trapezoid, if you don't have the height and it's given like this, always do base 1 plus base 2 over 2. If you have the angle in the side, you can do plus, let's call this alpha and let's call this L. Okay, L sine, sorry, ليش plus, sorry, times. It will be times L sine alpha. Okay, this always works if they give you the angle and the opposite side. Okay. Question 3, find the area of an equilateral triangle of side length 6. The area of an equilateral triangle is s squared radical 3 over 4. Okay, so the side is 6, so 6 squared radical 3 over 4. You're gonna get 9 radical 3. صح? 3 radical 3. 6 squared 36 divided by 4. Why? Wait. Yeah, so it's 9 radical 3, sorry. Okay, then what is the area of a regular pentagon of side length 8? So for part B, it took me a while to prove it, but from the proof I got, I can give you one formula, and this formula will always work for a regular pentagon. أول شيء, for any area of any polygon, the area A equals half the apothem times the perimeter. Okay, the apothem of a pentagon is S over 2 tan 36. Okay, always. This is how it is for the apothem of a pentagon. Okay, regular pentagon. يعني they won't get you anything that isn't regular in the exam. But المهم, so in this case here, the apothem will be 8 over 2 tan 36. So apothem is going to be approximately 5.5. So we want half the apothem times the perimeter. Okay, if each side is 8, 8, 8, 8, 8, how do you find the perimeter? It's 5 sides. 5 times 8, 40. So P equals 40. Okay, so I'm just going to do half times 5.5 times 40. Okay, and you're going to get 110. Okay. For question 4, it's pretty straightforward. It's just base 1 plus base 2 over 2 times height. Okay, please don't mix up and put 51 as base 1. Okay, base 1 is the total length, so 51 plus 7. Okay, that's the first base plus the second base 30 over 2 times the height, which is actually given the perpendicular height. It's 24. So you're gonna multiply these out, you're gonna get 1056. Question 5. Given a regular hexagon whose apothem is 10 radical 3, find the perimeter of the hexagon. So the apothem of a hexagon, okay, Remember, for pentagon, it was s over 2 tan 36. For a regular hexagon, it's s radical 3 over 2. Okay, so we know that the apothem equals 10 radical 3. So 10 radical 3 equals s radical 3 over 2. Multiply by 2 on the other side, you're going to get 20 root 3 equals s root 3. Divide by root 3 on both sides, you're going to get 20 equals the side. But they didn't ask for the side, they wanted the perimeter. And for the perimeter is 6 times the side. Okay, not 8, guys. Hexagon is 6. Octagon is 8. Okay, so s times 6 equals p. So 20 times 6 equals 120. 20 times 6 equals 120. Okay, question 6. The area of an equilateral triangle of side length 6 can be expressed in simplest form as a root b, where a and b are constants to be determined. Okay, the area of any equilateral triangle we said is s squared radical 3 over 4. So it's going to be 6 squared radical 3 over 4, which is 36 root 3 over 4, which is 9 root 3. So a would be 9, b would be 3. Yeah, a is 9. Did you just forget b? I'll give only the value a. Okay. Section 5.2, what do we need? Question 9 here. Here it says 8 and 9. So let's go to 8 and 9. Given M and N are the midpoints of A, B, and DC. Also given the area of the trapezoid ABCD is 75. They want the length of MN. So over here, they told us M and N are the midpoints of AB and DC. So yani M here splits AB into 2 equal segments, and N as well splits DC into 2 equal segments. Okay, also given the area of the trapezoid is 75. Okay, so yani B1 plus B2 over 2 times the height is 75. Okay, since n is a midpoint, that means this whole segment DC is double NC, right? So that means if I were to draw a line here, let's call it DH. Okay, DH would be double of, let's call this NM, right? Because DC is double of NC, it's similar. So if this is 3, it's also going to be here 6. So my height I know now is 6. So B1 plus B2 over 2 times 6 equals 75. Let me tell you something about trapezoids. The mid segment, okay, if these are midpoints, okay, this is what we call the median of the trapezoid, okay? I think it's called something like that, but it had a name. But my point is that another area of a trapezoid, we took this in grade 9, would be the median times the height. Because the median represents the average between the two segments. So the median is actually AD, we can call it M. The median M is actually AD plus BC over 2. Okay, that's what the median of a trapezoid is. Okay, so here, my median here is base 1 plus base 2 over 2. So my median is base 1 plus base 2 over 2. So I can replace this base 1 plus base 2 over 2 by my median MN, right? MN times 6 equals 75, and I get MN is 12.5. That's how it is. When they ask you to find the segment in the middle, okay, that represents the average between them. Okay, so you won't divide by 6 then multiply by 2. No. Okay, just divide by 6 because we want it in the form base 1 plus base 2 over 2. Okay, and you're going to get 12.5, yeah? Question 9, they're asking you to find the ratio of the areas. Okay, the ratio of the areas always area 1 over area 2 equals side 1 over side 2 squared. Okay, squared. So in this case, CPB over PAD. Okay, we have a side from each one. Very easy. We just need to know the corresponding sides. Okay, the corresponding sides, if it's in a circle, the corresponding sides will be the ones after each other. Okay. Oh, sorry. It's not the ones after each other. It's the ones beside each other. Okay, so this side will be corresponding to this side. Okay, if you want a proof for it, it's because if you connect this and this angle over here and this angle are congruent because they intercept the same arc. Okay, and since they're congruent, that means this side is corresponding to this side. So these sides, the ones beside each other, correspond to each other. This side corresponds to this one. Okay, so CPB, what's the side from CPB? We're taking 2, and the one corresponding to it on the other one is 5. So 2 over 5 squared, because it's side 1 over side 2 squared when you're working with areas, you get 4 over 25. After that, okay, before going on to 5.3, I figured out the question that we were doing somewhere over here, chapter 4. It was question 33. Um, where am I? Where am I? Where am I? Section. I chapter. Hold on. Let me find. Let me find it, guys. Wait. Okay, yeah, over here. The length of the height, ah. Okay. Over here, we said since this is a regular tetrahedron, that means all of these triangles are equal. Okay. Uh, and in an equilateral triangle, okay, let's say this is the midpoint of BC. If you connect this, let's look at BDC, okay? If you connect in an equilateral triangle from the vertex to the midpoint, okay, it's two things. It forms two things, okay? أول شيء, this is the midpoint. This is what we call the median of the triangle. Also, we know that it forms a right angle because the median of an equilateral triangle is also the altitude. Also, we know that this here, the height is falling on the centroid of the equilateral triangle. Okay, centroid meaning that mh equals 2 over 3. No, wait. mh equals 1 over 3 of the whole md, and hd equals 2 over 3 md. This is the rule of the centroid. Okay, we took this back in grade 9. So, can we find md? Can we find md? We said here was m. We connected these. We said here was m. Can we find it if we know this is right? We know this is 15 because it's the edge, right? And this is the midpoint, right? So if this was all 15, that means it would be 7.5. All the sides here are 15 because it's regular tetrahedron. Okay, so can you find here? What is it here? You do 7.5 squared plus 15 squared, and 7.5 squared plus dm squared equals the hypotenuse squared, which is 15 squared, and you're gonna get approximately 13 over here. Okay, طب we know the AH is a height. What does it mean? It means it's perpendicular to the base, right? I know it might not look like a right angle, but the figure is not to scale. So in this triangle over here, we want the length of AH, right? Do we know the length of AD? We do. And we know it's 15 because all of the edges here are 15. So can I find it here? Let's call this AH is X. We know it's a right angle triangle, so the hypotenuse, we have hypotenuse here. So since we can just do Pythagoras theorem, since it's a right triangle, x squared plus 13 squared equals 15 squared. So you do 15 squared minus 13 squared and find the square root, and you get AH is 12.2. So you write AH is here 12.2. Okay, then they want the angle between AB and the plane BCD. So if you look here, between AB, okay, and BCD, right? So it's gonna be this angle over here, right? And we know that you can just connect it over here. And we know this is a right triangle because it's a height. We know that this side is AH, is 12.2, and we know AB is 15, right? Because it's a regular tetrahedron, so all sides are 15. So can I find this angle here? I have the opposite side, I have the hypotenuse. So sine, let's call it alpha, equals opposite over hypotenuse. So it's gonna be 12.2 over 15. So you just do shift sine of 12.2 over 15, and what do you get? 54.4. Okay. The angle between any two faces of the tetrahedron, okay, okay, between any two faces of the tetrahedron, in the solution they picked between these two faces over here. So they picked this angle over here between this face ABC and the base BCD. Okay, so I mean that works, I guess. So they wanted this angle here. Okay, and we can find this angle out. We have this side, which was what was this side of the wait, hold on. Yeah, we got that MD here was 13. If MD is 13, this is also 13 because this is running through yani. They're both equilateral. They're all yani equal triangles. So the line running through it would be equal to the line running through it over here. Okay, so 13, 13. Okay, and we know that AD is obviously 15 because it's a tetrahedron of edge length 15. So can we find the angle when you have all three sides? Yes, cosine of the angle equals the angle opposite to it squared minus the other two angles squared, 13 squared minus 13 squared, over minus 2 times the other two sides, So you just do shift cosine and you're gonna get 70, I think uh, 70.7. So a question like this wouldn't come, but yeah, just in case, guys, you never know. Okay, question 10. Given a circle's circumference is 10 pi, find the area. You know the area of a circle is pi r squared. This question always comes. Okay, and we know we need the radius and we have the circumference. You know the circumference is 2 pi r. Okay, and they told us it's equal to 10 pi. Pi with pi, divide by 2 on both sides, you're gonna get r equals 5. So over here I plug in pi times 5 squared. Okay, you're gonna get 25 pi. صح? 25 pi. Okay, question 11. They're asking for the length of AC, the arc. Okay, they were supposed to put the arc symbol. Okay, because I was confused. I was finding the length of the actual line AC. Okay, but the arc symbol here, they should put it. Okay, how do you find the length of an arc? It's theta over 360 times 2 pi r. Okay, so we need the angle for this arc, so we need this angle over here. Okay, and I think you guys from chapter 1 know how to find this angle over here. Okay, we know that this is 90, this is 90, and if this is 60, we know that this is a quadrilateral, this is a red quadrilateral, yeah. Okay, how would you find you know the sum of all angles in a quadrilateral is 360, so this is 90 over here because the radius is perpendicular to the tangent, and here for the same reason as well. So 90 plus 90 plus, let's call this angle x in the middle, plus 60 equals 360. You're gonna get x equals 120. Okay, so the angle is 120. So 120 over 360 times 2 pi times the radius is 8, right? You're gonna get 16 pi over 3, I think. Yeah, 16 pi over 3. You got, because this is gonna be 1 over 3 times 2 times pi times 8 is 16 pi. Okay, you're gonna get 16 pi over 3. Okay, question 12. The length of AB is 10 centimeters and the measure of angle AOB is 60 degrees. Calculate the area of sector AOB. Well, you should draw. Ya Allah. So we know that the center is O, so they should draw it for you. Over here you have O. Okay, the length of AB is 10 centimeters. The measure of angle AOB is 60 degrees. So let's say is A here and B here. Okay. Again, they were supposed to tell you this is arc AB. I don't know if there's something wrong with my computer, but yeah, the arc symbol is not showing. Um, yeah, it's not showing for some reason, but they should in the exam tell you it's the length of the arc. We know the length of the arc is theta over, theta over 360 times 2 pi r. Okay, we don't know the radius. Okay, we know that the angle of it is 60, right? We know the angle is 60, so 60 over 360 times 2 pi r, and we know they told us the length is 10. So can we calculate r? Yes, we can. 60 over 360, 66. You get 1 over 6 times 2 pi r equals 10. Okay, multiply by 6 on both sides, you're going to get 2 pi r equals 60. You're going to get pi r equals 30 because you divide by 2. You're going to get r equals 30 over pi. Okay, so can we find the area of the sector? Yes, we can. It's going to be theta over 360 times pi r squared. So here we can do, we know the angle is 60 over 360 times pi times 30 over pi squared. You should put this in a calculator. What do you get? You get 150 over pi. Okay. Question 13. 13 always comes. Okay, they said the radius is 10. Calculate the area of the shaded region. Area of the shaded region is always area of the sector minus area of the triangle. Okay, the sector here is 90, right? The angle is 90. So 90 over 360 times pi r squared. Okay, because the area of a sector is theta over 360 times pi r squared. So it's going to be 1 over 4 because 90 over 360 times pi times r squared, so 10 squared, so 100. Okay, you're going to get 25 pi. So area of the sector is 25 pi. Can I find the area of the triangle? Yes, I can, right? Base is 10, height is 10. So it's going to be 10 times 10 over 2. So it's 50. So the area of the shaded region will be 25 pi minus 50. Is this correct? Yeah. Oh, they wanted to keep it like that. So that what they did, they took 25 out. They wanted to keep it in terms of pi, and it became pi minus 2. This is your answer. Centimeters, huh? Centimeter square. A, B, C, D. How many questions are here? 10 to 15. So the whole thing, yeah. Oh no. Oh, okay, it's calm, it's calm. A, B, C, D, E, F is a regular hexagon inscribed in a circle. Calculate the shaded area. Okay, so the shaded area obviously here would be the area of the circle, right? Or area of the whole circle minus the area of the hexagon. Okay, and we know that the area of the hexagon equals half AP. Okay, the perimeter, they gave you the radius, so that means if this is 16, the side is 16. Okay, they didn't give you the apothem, they gave you the radius here. Okay, be careful, they gave you the length of the side. Okay, so we need the apothem and we need the perimeter. Let's start with the apothem. We know that the apothem of a hexagon is s radical 3 over 2. So in this case, it's going to be 16 radical 3 over 2, which is 8 root 3. So we got the apothem. The perimeter will be 6 times the side. So it's going to be 6 times 16. So it's going to be 96. Okay. We want half times the apothem, 8 radical 3, times 96. You're going to get, I don't know, bro. What do you get? Whatever it is. Let me do it on my calculator. 384 root 3. Okay. Can we find the area of the circle? The area of the circle is obviously just pi r squared. So it's going to be, so on a calculator 384 radical 3, it might give you 665. But I just multiplied the coefficients and kept it in terms of radical. Let's just put it as 665. Okay, pi r squared would be pi times the radius squared, so 16 squared, which is 16 squared times pi. It's 256 pi. So 256 pi minus 665. Yeah, so the area shaded equals 256 pi minus 665. And you should get 139.2. 139.2. Is this correct? Oh, 0.14. Okay, whatever. And I got 0.24. Oh, well, it doesn't matter. It doesn't really matter. It's to 1 decimal point, right? That doesn't really matter. Okay, 15. Calculate the shaded area. Akid, the shaded area here would be the area of the square minus the area of the circle, right? The area of the square is obviously side times side, so it's going to be 144 minus the area of the circle. Okay, they gave us the length of the side, so they gave us the length of this actually, right? And this is actually the diameter. Okay, we know the area of the circle is pi r squared. Can we find the radius if we have the diameter, which is 12? Okay, yes we can. The radius is 12 divided by 2, which is 6. So pi times 6 squared, which is 36 pi. Okay, so 144 minus 36 pi. 144 minus 36 pi. You get 30.9. Okay, is that correct? Yeah, 30.9. Okay. That's it, I think, for this one. Now 5.4. Yeah, 5.4. Yeah, for now we're on question 33 and 5.4. What is the mass of water in a cylindrical can, height 20 centimeter and radius 5 centimeter? Okay, they said that 1 milliliter of water has a volume of 1 centimeter cube, and each centimeter cube has a mass of 1 gram. If we can find the volume, we can actually find its mass, right? So let's find its volume. It's a cylinder, okay, and you know the cylinder volume of a cylinder, okay, is pi r squared h. Okay, and here is going to be pi times r squared, so 5 squared, times 20, and it's going to be 250 pi. 250? No, 2500 pi. Okay, so how did I get? Wait. 20. La. So 120, 25 times 20. Yeah, 500 pi. Sorry, 500 pi milliliters, right? Or centimeter cube, whatever. Okay, and each centimeter cube is 1 gram, so it's 500 pi grams. Yeah, 500 pi grams. Question 34. A sphere has, is it just 33, 34? Okay, we're skipping 36, 37. Okay. A sphere has a volume of 288 pi. Calculate the radius. Okay, the volume of a sphere, okay, is actually 4 over 3 pi r cubed. So أول شيء you have to it equals 288 pi, right? They said it's good. أول شيء cancel pi with pi, then multiply by, sorry, divide by 4 over 3. You're gonna get r cubed equals, let me do it on my calculator. 288 divided by 4 over 3, you get 216. Then you have to cube root it. Okay, the cube root of 216 is 6. Okay, so the radius is 6. Then the surface area of a sphere is 4 pi r squared. Okay, so you're gonna do 4 times 6 squared, 36 times 4. So you're gonna get 144 pi. The surface area of a sphere whose radius is double the radius of the given sphere. Okay, we know that area 1 over area 2 is side 1 over side 2 squared. Alright, so we said the radius is double of the given sphere. If we were comparing spheres, then obviously we'd be comparing radii for the radius. Sorry, for the sides. So area 1 over area 2 equals radius 1 over radius 2. Okay, let's call the bigger radius R1 and A1. So the bigger sphere will be the one on top. And we know that its radius is double the radius of the given sphere. So the radius 1 given, the bigger one, is actually 2 times the second radius, yeah? So we can replace, this is sorry, supposed to be squared, side 1 over side 2 squared. Okay, this is supposed, this radius 1, we can replace it with 2 times radius 2 because it's double the smaller center. So actually let's call this big R, let's call this small r. Okay, so the big R is equal to 2 times the small r. So area 1 over area 2 will be equal to, the big R we said is 2 times the small r, so 2r over r squared. So area, we can cancel r with r. You're going to get area 1 over area 2 equals 2 squared. So area 1 over area 2 is 4. Okay, we know that we don't know the surface area for the big one, but we do know that the smaller surface area we found it is 144 pi. So area 1 over 144 pi equals 4. How do you find area 1? You just cross multiply, صح? And you're gonna get oh shit, you could do that. Can you? 144. Okay, yeah, I mean, I guess you could do it like this. Yeah, why am I stupid? Ah, am I stupid? Wait, yeah, you could have just done surface area is 4 pi r squared, and the radius is double. If this was 6, then akid is 12. Oh shit, my fault, guys. 12 squared. So it's gonna be 576 pi. Okay, yeah. Okay, my fault. Question 35. Yeah. Compare the volumes of two cylinders with the same height, but the radius of one is 1/3 of the other. Okay, we know volume 1 over volume 2 is radius 1 over radius 2 cube. Okay, let's call, now you use this one. Let's call the bigger radius, okay? It's 3 times the small radius, yeah? Because one of them is 1/3 of the other. Okay, so let's call this the bigger volume. Okay, volume 1 over volume 2 equals the bigger radius, right, over the small radius. Okay, the bigger radius you said is 3 times the small radius. 3r over r cubed. Cancel r with r, you get v1 over v2 equals 3 cubed. So v1 over v2 is 9. So that means the bigger cylinder is 9 times the smaller cylinder. Okay. Wait, why is it, if v is the volume of the cylinder with radius r, and v prime is the volume of the cylinder with radius 3r, then v prime 3 cubed is 27, and I solved it wrong. My fault. Again, I don't know what's wrong with me. Sorry. The first volume, okay, the way they solved it, the first volume is pi r, because they said same height. If they don't say same height, then you use the way I solved. But since they said same height, it's pi r squared h. Volume 2, okay, is pi, let's say volume 2 is the big one, pi times r squared h, with the bigger radius, yeah? But it's the same pi, same h. Okay, we know that this r is 3 times the small r, right? Because they said 1/3. Okay, so we can replace this with pi 3 r squared h. Okay, how do we compare this to the first one? We just equal it. Okay, cancel h with h and pi with pi. You're gonna get 3r squared outside equals r squared. Okay, you're gonna get 9r squared equals r squared. So you're gonna say it's 9 times bigger. Okay, if it comes, just square, bro. 3 squared, 9. That's it. 36, 37 we skip. 38. They want 38. Yeah. 38. Yeah. What is the lateral area of a right circular cylinder whose height is 10 over pi and its base radius is 9? Okay, the lateral area of a cylinder is 2 pi r h. Okay, of a cylinder. So in this case, it's going to be 2 times pi times the radius, which is 9, times the height, 10 over pi. Obviously, cancels pi with pi. You're going to get 180. What is 38? Yeah, 180. What's after 38? 39, 40, 43, 44. 39, what is the radius of a cylinder whose height is 9 over pi and its volume is 234? Okay, we know that the volume of a cylinder is pi r squared height. Okay, and they said this is equal to 324. We know its height is 9 over pi, so pi times r squared times 9 over pi equals 324. Pi with pi, you get 9r squared equals 324. So r squared will be equal to 324 divided by 9. 324 divided by 9, and you get 36. So you get r equals 6. Okay, then 40, given two cylinders of the same height, the radius of one is 7 times the radius of the other. Okay, it's gonna be, if you use the same rule we used before, told you when they say same height, one is 7 times the radius of the other, you square it. Okay, it should be 49. Is it 49? 49. Yeah. The actual way to do it though, since it's the same height, we can say v1 is pi r squared h. Okay, and then we can say v2 is the smaller one, which is pi r squared h. We know that the bigger one is 7 times the smaller one, so we can just replace this with pi times 7r squared h, which is 49 r squared h pi, and compared with this, cancel h with h, pi with pi, r squared, you get it's 49 times bigger. Okay, what do they want now? 43, 44, 45. Okay, what is the volume of a regular square pyramid whose height is 15 and the length of the side of its base is 8? Okay, the volume of a square pyramid, okay, the volume of square pyramid is 1 over 3 bh, okay, where b is the area of the base and h is the height. Okay, since it's a square base, the area of its base, if it's side 8, the area of the square with side 8 is just 8 times 8, which is 64. Okay, so it's going to be 1 over 3 times 64 times the height 15. Instead of b, you could say s squared maybe, whatever. But here you're going to get 5 times 64. 320. Yeah, 320. 44. What is the radius of a sphere of volume? Okay. The volume of a sphere is 4 over 3 pi r cubed. Okay, and we said it equals 5324 over 3 pi. Pi with pi. Divide by 4 over 3, you're going to get 5324. Yeah, you're going to get r cubed equals 1331. Yeah, 1331. Yeah, and you're going to get r equals the third root of 1331, which is 11. Okay, 45. The surface area of a sphere. Okay, they want the surface area of the sphere that has a volume of this. Okay, the surface area of a sphere is 4 pi r squared. Okay, the volume of a sphere is 4 over 3. Volume equals 4 over 3 pi r cubed. So we need the radius first, right? And the radius in this case, we have to find it. They told us the volume is equal to 8,788 over 3 pi. Pi with pi, 3 with 3. Okay, we divide by 4 over 3. You're gonna get r cubed equals 2197. So I think it's 13. You get r equals 13. Okay, then you want to check 4 pi r squared. You just plug it in, so it will be 4 times pi times 13 squared. Okay, It's gonna be 676. Is it 676 or when I went back? Yeah, 45, 676. What comes after 45? Okay, these are the last. The written will come from one of these four. Okay, to be more specific, it's probably 79, 80, 81, one of them. Okay, yeah, one of these three will be the written. Okay, so they said 70. Oh, she's 70. Let me scroll down to 70 over. How far is it? Okay, a container has a surface area of 5,000 centimeter cube and a capacity of 12.8 liters. Find the surface area of a similar container which has a capacity of 5.4 liters. Ah, no, I'm solving 69. My fault. Question 70. A sphere has volume 288 pi. We solved this, no? We'll do it anyway. Okay, volume is 4 over 3 pi r cubed for a sphere equals 288 pi. Pi with pi. Divide by 4 over 3. Divided by 4 over 3. You get r cubed is 216. You're gonna get r equals 6. Surface area of the sphere. We know surface area is 4 pi r squared. Okay, so it's gonna be 36 times 4. It's gonna be 144 pi. I think we solved this question. The surface area of a sphere whose radius is double that of the given sphere. Again, 4 pi r squared for the surface area, but the radius is double, so it's going to be 4 times pi times 12 squared, so double of 6. Okay, and you're going to get 576 pi. Okay, question. Now we're at the possible written 79, 80, and 81. Top questions. The diagram below shows a square pyramid ABCDE. The diagonals of the base intersect at point O. AO is 10 centimeters long and its height, it is the height of the pyramid. DC equals 8 centimeters. It's a square pyramid, that means if this is 8, this is 8, this is 8, this is all 8. Okay, find to one decimal place the measurement of segment CO. CO, right, will be half the measure of CE, right? And CE is actually the diagonal of the square. And you know, since it's a square, if this is right, okay, this can be a triangle. We can use Pythagoras theorem to find CE, right? We can use Pythagoras theorem. If this is 8, this is also 8, right? Because it's a square. Okay, can we find the length of CE? Yes, we can. 8 squared plus 8 squared equals CE squared. You're going to get CE squared equals 8 radical 2. Okay, after you solving, you get CE equals 8 radical 2. Okay, so this is 8 radical 2 for the whole thing. Now, what did they ask for? They asked for CO, which is half of it, right? It's up until O only. So if this was all 8 radical 2, it's going to be half of it. So it's going to be 4 radical 2. Okay, to one decimal place, that would be, do on my calculator, it would be 5.7. Is that correct? Oh, wait, no, wait. 78, 79. Okay, you get 5.7. Okay, find to one decimal place the measure of the angle CAO. CAO. So we want over here. CAO. We know this is 5.7. We know this is 10. This is a right triangle. Okay. So can we use we're going to use one of the rules, right? Sine, cosine, or tan. What do we have? We have the opposite side. And we have the adjacent side. When do we use opposite over adjacent? When we're working with tan, right? So tan of this angle is called A. Okay, tan of A equals opposite side, which is 5.7 over 10. How do we find A? It would be shift tan 5.7 over 10, which is shift tan 5.7 over 10. You should get to one decimal place. It will be 29.7 degrees. Is that correct? 29.7. Okay, then they said find the volume of the pyramid. Find the volume is very easy. Okay, here it was, what did we say, 5.7. Here 29.7. Now find the volume of the pyramid. The volume of the pyramid, very simple. 1 over 3 b h, right? Area of the base times height. So 1 over 3 times area of the base, if it's 8, so it's a square, and the side, the area of a square is 8 squared, so 64, times the height, 10. you're gonna get 213.3. Well, yeah, 213.3. Okay, this one's pretty simple. Inshallah, they bring this. Question 80. Find the volume of a sphere. Ah, this is the one we always get in the computer. Find the volume of the sphere of radius 3 centimeters, correct to 3 significant figures. Okay, so the volume of a sphere is always 4 over 3 pi r cubed, right? So it's going to be 4 over 3 times pi times 3 cubed. Okay, put this in a calculator. You're going to get to how many? 3 significant figures? 113. And I got 113. Is it correct? 113, yeah. The sphere is placed in a cylindrical container of, we got 113, of radius 8 centimeters filled with 2 liters of water. Calculate the new height of the water in the container. Okay, so it's the volume, right? When we're working with volumes of water, when working with the measurements of water, we're working with volumes, cube. So we're working with what shape here? We're working with a cylinder container, right? And what's the volume of a cylinder? It's pi r squared h, right? So do we know what the volume of the cylinder is? It's 2 liters of water, which is 2000, right? 2000 centimeter cube. But so what did we add to it? We added the sphere from part A. So the volume is 2000 centimeter cube plus 113 centimeter cube from part A. So it's 2113 centimeter cube. So I can replace this volume here with 2113 centimeter cube equals pi times the radius. Do we know the radius? They said it's 8 centimeters. So 8 squared times the height. Can I find the height? Of course I can. Just divide by 64 pi because 8 squared. So h will be 2113 divided by pi divided by 64. Okay, because 8 squared 64. So 2113 divided by 64 pi, you get 10.5. Is it 10.5? Yeah, 10.5 centimeters. There is a part C. Okay, this is a completely different question. The diagram below shows a cone with radius 4x centimeters and the slant height 18 centimeters and a sphere of 3x centimeters. If the surface area of the cone is equal to the surface area of the sphere, find the value of x. The surface area of a cone, okay, is equal to pi r squared plus pi r l. Okay, the surface area of the sphere is equal to 4 pi r squared. They're saying they're equal, so pi r squared plus pi r l is equal to 4 pi r squared. Okay, to make our lives a bit easier, we can subtract by 1 pi r squared on both sides. You're going to get pi r l equals 3 pi r squared. Okay, just to make our lives a bit easier when solving. Okay, can we substitute now? Yes, we can. Cancel pi with pi, by the way. You're going to get rl equals 3r squared. Okay, this is radius of... Wait. Sorry, no. You can only do this when the radii are equal. My fault. Surface area of the cone. Let me repeat. Surface area of the cone. You can't cancel. You can't subtract any the radius here by the radius here because this is 4x, this is 3x. You can't any. Okay, surface area of the cone. We said it's pi r squared plus pi r l. Surface area of sphere is 4 pi r squared. Okay. The first surface area. So we said they're equal to each other. So pi r squared plus pi r l equals 4 pi r squared. What you can do is cancel pi from everywhere. Okay, cause that's odd. You can do that because pi is equal on everywhere. So r squared plus rl equals 4r squared. So here we're talking about the cone. Why did I write the pi again? Plus 4r squared. Here we're talking about the cone. What's the radius of the cone? It's 4x squared, right? 4x squared plus the radius again times the slant height. 4x times l, 18. So times 18 equals 4 r squared. 4 r squared here is 3x, so 4 times 3x squared. Let's simplify this. It's going to become 16x squared. This is going to become 72x equals 9, 36x squared. Let's move everything to one side. Okay, let's move everything to the right. You're going to get 36x squared minus 16x squared is 20x squared minus, this comes minus 72x. Can we take, you can take 4x out, becomes 5x minus 18. Okay, can we solve this? Equals 0, yeah? Can we solve this? We get two solutions. We get x equals 0 and we get x equals 18 over 5. Okay, akid 0 is rejected. Okay, so your only x is 18 over 5. Okay, in the solution, it's wrong because they used the lateral area of the cone. In the question, it says surface area. Okay, pi RL is the lateral area, and that's wrong. If they told you if this lateral area of the cone is equal to the surface area, then this solution would be correct. But Anna, I solved for you according to what the question asks. Question 81. If two identical balls are inscribed in a cylinder whose height is equal to twice a sphere's diameter. Okay, so the height is equal to 2d. Okay, if the radius is 5 centimeters, okay, calculate the volume between the cylinder and the balls. Give your answer to 2 decimal places. So they want this volume here, like this shaded stuff. Okay, so obviously that volume will be the volume of the cylinder, right, minus the volume of the balls. Okay, the volume of the cylinder will just be pi r squared h, right? And that would be r is 5, so pi times 25 times h. So 25 pi h. Okay, this is the cylinder. The balls, we have two of them. Okay, let's find one. The radius, sorry, it's the each one is a sphere. Okay, and each sphere, the volume of a sphere is 4 over 3 pi r cubed, right? So you're gonna get 4 over 3 times pi times the radius cube is 5 cubed, so 5 cubed. Okay, you're gonna get let me see, 4 over 3 times pi times 5 cubed. You're gonna get 500 pi over 3. 500 over 3 pi. Okay, so we're gonna want 25 pi h minus 500 over 3 pi. So we can't subtract it. What's the height? Okay, what do we say the height is equal to? 2 times the diameter. And what is the diameter? Diameter is 2 times the radius. So let's see here. This is a radius, yeah? This is the height. Okay, so I can explain. This is a radius. Then this is another radius. Okay? And this is another radius to the center. And this is another radius. So I have 4 radii, yeah? So the height is equal to 2 times the diameter, which is each diameter is 2 radii. So 2 times 2 radii, 2 times 2r is 4 radii. So the height is actually 4 radii. And this is how, just so I can prove it for you. And we know that the radius is 5. So the height is 4 times 5, which is 20. Okay, so here 25 pi times the height 20 minus 500 over 3 pi. Okay, do this on a calculator. 25 times 20 times pi minus 500 over 3 pi. You get 1 to 2 decimal places, 1047.2. Is that correct? They got, oh shit, what did I do wrong? Saw. It's two spheres, right? And I only found the volume of one sphere. Okay, so this should be 500 times 2 should be 1000. Okay, so minus 1000 over 3 pi, right? Because we have to multiply the volume of the sphere by 2 since we have two spheres. So let me repeat the calculation again. I get 523.5. I get 523.6. Okay, 0.3. It doesn't really matter. The points don't really matter as long as you show your work properly. The answer key isn't one specific answer, by the way. It's a range of answers. Okay, and if your working is correct, then that's fine. Okay. Yeah. For pi r squared h equals, okay, make sure you show and know it's 2 times 2. Yeah, you have to make sure to show them and you did times 2. Just so the corrector understands how you got this 1000. Say times 2 because 2 balls or 2 spheres. Okay, so we got 523.4. 523. What did I get? Point 6, and I got on my calculator. I think also you get also the answer key is wrong, and I checked it in class. I was with my teacher. If the volume between two balls and the cylinder is equal to 113, find the value of r. We said that the space between the balls was equal to the volume of the cylinder minus the volume of the balls, right? Okay. The volume of the cylinder we said is pi r squared h minus the volume of the balls was 2 times 4 over 3 pi r cubed. Yeah, because it was 2 balls. and each ball is a sphere, which is 4 over 3 pi r cube. We said this is equal to 113 centimeters cube. Okay, can you find r? Yes, you can. Let's take this 2 inside because it's annoying when it's outside. Pi r squared h minus 8 over 3 pi r cube equals 130 centimeters cube. Okay, can you find r? Yes, we can. But before, you know what? Yeah, let's start by dividing by pi. Okay, let's divide by pi on both sides. Okay, you're gonna get, you're gonna get, let's keep it in terms of pi, r squared h minus 8 over 3 r cube equals 113 over pi. Yeah. Now, let's, we have to get rid of this h. How do you get rid of this h? Remember, we said that the height is equal to the 4 times the radius, right? Each height is 1 radius, 2 radius, 3 radius, 4 radius. So each height is 4 radii, right? So can I replace this height by 4r? Because we want to find the radius, so it would be ugly to have another variable, right? So r squared times 4r minus 8 over 3 r cubed equals 113 over pi. Okay, r squared times 4r is 4r cubed minus 8 over 3 r cubed equals 113 over pi. Then you just solve this like a normal equation. 4 minus 8 over 3 is 4 over 3 r cubed, right? 4 r cubed minus 8 over 3 r cubed is 4 over 3 r cubed. Just do it on your calculator. 4 minus 8 over 3 equals 113 over pi. How do we solve this? We have to divide by 4 over 3. So let me see this. 113 over pi divided by 4 over 3. You get 26.976. Okay. Yeah, the answer is you get 26 point something something something. You get 26.976. Okay, you can approximate it to 27. Okay, you can approximate it to 27, but you have to show the approximation sign. Huh? Don't put equal. Okay, don't put equal. Show the approximation sign. So it's like it's a equal but like curved lines. So r cube is approximated to 27, and if r cube is approximated to 27, r will be approximated to the cube root of 27. So r is approximately 3. Okay, that's the value of r. And then I think part C they asked. Yeah, there's part C. Part C. The diagram below shows an iron sphere of radius 6. The sphere is melted and made into small cones of diameter 2 centimeter and height 2 centimeter. Calculate the number of smaller cones that can be made. Obviously, if we're melting and making it into other shapes, that means we're talking about the volume. Can we calculate the volume of this sphere? Yes, we can. The volume of this sphere is equal to 4 over 3 pi r cubed. So it's going to be 4 over 3 times pi times 6 cubed, which is going to be 288 pi. Okay, we want to know how many smaller cones we can make. So obviously we have to divide the number of the big volume by the volume of each cone to see how many small cones we have. What's the volume of a cone? The volume of a cone is 1 over 3 pi r squared. So if you substitute, it will be 1 over 3 times pi times r squared. If the radius is 1, so it's 1 squared times the height, which is 2. So you're going to get 2 over 3 pi for the volume of the cone. So can we divide 288 pi by 2 over 3 pi? You can cancel pi with pi. Just do 288 divided by 2 over 3 and you get 432. So you say 432 smaller cones will be made. If you want my opinion, Saraha, I think they're going to get this one. Okay, because this one came in a multiple before. So I think they'll get it in the multiple, this one. And this one came in like something similar to it came in our written. So I don't think they'll get this. I really think they're going to get 81. Okay, but don't take my word for it. I'll study all three. أنا at the end of the day I don't know. This is just a prediction. Okay, I think we're done. Thank you so much for watching. Good luck in your geometry final.